Strategy 3, exact mathematical analysis. Well, one disadvantage that we've seen using the simulation to calculate probability is that everyone can get potentially a different answer, and the resulting probability is still only an estimate of the actual probability. So we need a few definitions, we need some new terminology. The first one is sample space, and you'll notice we will write with a capital S, but what is sample space? The sample space of a random process is a set consisting of all possible outcomes. Okay, so we need all possible outcomes usually written out, or we need to know what the count would be so that we can calculate the probability. Now, if all the outcomes are equally likely, so the outcome has to be equally likely, then the probability of the event in question is the number of outcomes in the event divided by the total number of outcomes in the sample space. This is often sometimes called the classical approach to probability. An event is a collection of outcomes, and you often see it denoted by a capital letter. So let's see how that would work. For this example, we can compute the exact probability of 0 matches. We start by listing out all possible arrangements of the 4 different phones being returned to the 4 different owners. Well, let's think about it first of all. When returning 4 phones randomly to their respective owners, how many possible arrangements are there? And you're like, well, I can see it right here. It's 24. But before we even write it out, we can actually calculate that number so that we can then check to make sure that we've got all of our sample space is complete. So what do I mean? We start out with 4 phones on the ground. So the first person who picks up a phone will have how many choices? Well, hopefully you say 4. So the first person has 4 choices. How many choices does the second person have? If one phone has been picked up, how many are left? And hopefully you say, oh, there's got to be 3. Consequently, there's 2 left, and then there's just 1. And when you multiply this out, you get 24. And written below is actually all 24 possible arrangements. Now, you may be like, well, where are the letters like Jack, Queen, or King, or somehow? Well, what we did instead is we said arrangement, we did by 1, 2, 3, 4. So the numbers 1, 2, 3, 4 means that the first person got their phone, the second person got their phone, and the third and the fourth person got their phone. So that means that there were 4 matches. Everyone got their phone back. Whereas 1, 2, 4, 3 means that the first person got their phone, the second person got their phone, but then the third and fourth, they were flipped. So here we go. Here they're all listed out. Now it says list all the arrangements with 0 matches. How many are there? Well, you may be like, ugh, this is going to take a while to do. Yeah, it's a little bit time consuming, but there are a couple quick little tips and tricks. Sorry, I was getting that one backwards there, that you can use. First of all, anything that starts with 1, you know that the first person got their phone, right? So remember, we're looking at 0 matches. Anything that ends in 4, you know the last person got their phone. And once again, you can see, well, and then this ends in 4 also. And that helps take down the number quite a bit. So then you have fewer to look at. You also know if this number 2 is in the second space, then that person got their phone. And now there are many fewer to look at. So take a moment and see if you can come up with the list of the number that had 0 matches and write them down. So take a moment, check and see if you got all of these. There are a total of 9 where none of them matched. So what's the exact probability of 0 matches when returning 4 phones to the 4 owners? So we're going to start using good notation, the probability of 0 matches. So this tells me I'm looking for the probability of what is how I think about that. Remember, We're going to take the number of times it happens, the event of interest, in this case, 0 matches, over the total size of the sample space. And obviously, you would do that with a calculator. How does the exact probability compare to the probability calculated using the computer simulation? Well, using the computer simulation, we got 0.373 with 10,000 reps and 0.356 with 1,000 reps. So those numbers look pretty close to me. Now, complete the following table to display the exact probability to 3 decimal places for each possible value of the number of matches. Well, we did the first one. We did that, 0.375. We know that this can never happen. So the probability of 3 is 0. Remember, the probabilities of total across have to add to 1. Okay? We know that they can all match only one time. And then if you do the counting up, you'd have 8 times that exactly there was one match, and 6 times there were 2 matches. And when you do the division, here's how it works out. This is a probability distribution table, and we'll talk more about these as we go along. But each of the probabilities is between 0 and 1, including 0 and including 1. So, and the probabilities total to 1, so it all looks pretty good. So let's talk about some more definitions. A probability model describes all possible outcomes and assigns probabilities to them. Legitimate probability models must obey 4 rules. Any probability must be between 0 and 1 inclusive, in other words, between 0 and 1 hard brackets, or you can say 0 is less than or equal to the probability is less than or equal to 1. All probability outcomes together must have probability 1. So once you add across, you add them all up, it has to total 1. Now, things that will also happen, the probability that an event does not occur is 1 minus the probability it does occur. And we'll be working with that as we go along. But these, when we're checking to see if it's a valid probability model, this is the 2 that we're really focused on. The last thing that's important to consider for a probability model, if 2 events have no outcomes in common, so they're mutually exclusive, so they have no outcomes in common. In other words, you can't have 0 matches and 1 match at the same time because it's either 0 or 1. They both can't happen at that same moment. Then the probability of one or the other is the sum of their 2 probabilities. And we're going to use these, and we'll come up with a table that summarizes these rules a little bit later. Does the table of outcomes, this is letter F, and probabilities in the table above in E represent a legitimate probability model? Explain. Well, yes, it does. We've already spoken about it. Each probability is between 0 and 1. Including 0 and 1. And the sum of the probabilities is 1.